Hi friends, welcome to all. In this video we are going to see the lab activity configuring 802.1q trunk based inter-VLAN routing. Before coming to this lab activity, friends, if you are watching my channel first time or if you are not yet subscribed to this channel, consider subscribing. Also enable the bell icon near to the subscribe button so that you will get the notification message when I upload the new videos. Well, here we can see our addressing table, also switch port assignment specifications. We will go through the objectives. In part 1, build the network and configure basic device settings. In part 2, configure switches with VLANs and trunking. In part 3, configure trunk-based inter-VLAN routing. Also coming to the background of this lab activity, a second method of providing routing and connectivity for multiple VLANs is through the use of an 802.1q trunk between one or more switches and a single router interface. This method is also known as router on a stick inter-VLAN routing. In this method, the physical router interface is divided into multiple sub-interfaces that provide logical pathways to all VLANs connected. In this lab, we will configure trunk-based inter-VLAN routing and to verify connectivity to hosts on different VLANs as well as with a loopback on the router. Here we can see the required resources for this lab activity. One router Cisco 1941, two switches Cisco 2960, then two PCs, console cables, then Ethernet cables as shown in the topology. Right, coming to part 1, build the network and configure basic device settings. In part 1, we will set up the network topology and configure basic settings on the PC's host, switches and router. Coming to step 1, cable the network as shown in the topology. Here we are going to implement this lab activity using Cisco Packet Tracer. Here we can see the topology. We are going to build and connect as per the topology here. Well, we needed one router 1941, two switches, then two PCs. Also, we will rename these devices as per our topology. This is R1. Here we have S1. This is S2. This is PC-A. And this is PC-B. Now we will connect these devices. Coming to connections, copper straight through G0/1 to F0/5, F0/6 to this PC-A, F0/18 to this PC-B. Now we will select copper crossover to connect these switches S1 and S2, F0/1, F0/1. Now we will label the port information. This is a G0/1. Here we have F0/5. This is F0/1. Here also F0/1. This is F0/6. Here we have a F0/18. Also we will mention the VLAN trunk. Here is that. Also we will label here 802.1q VLAN trunk. Coming to step 2, configure PC host. Coming to our addressing table, here we can see the IP address of PC-A and PC-B. We will copy this address. Coming to PC-A, desktop IP configuration. Here is the IP address, then the subnet mask, also the default gateway, it's 10.1. Here is the IP address of PC-B. Here we can see the subnet mask and the default gateway. Coming to PC-B, desktop IP configuration. Here is the IP address, subnet mask, default gateway is at 20.1. Coming to step 3, initialize and reload the router and the switches as necessary. Right, coming to step 4, configure basic settings for each switch. Console into the switch and enter global configuration mode. Copy the following basic configuration and paste it to the running configuration on the switch. So here we can see the commands what we have to give on the switch. We'll copy this command and we will put it on a notepad. We will copy these commands and first of all we'll put it on the switch S1. Enable configure terminal. Here we are going to paste those commands. Now we will come to the switch S2, CLI, enable configure terminal, and here are those commands. Next is configure the device name as shown in the topology. Configure the IP address listed in the addressing table for VLAN 1 on the switch. Configure the default gateway on the switch. Then administratively deactivate all unused ports on the switch. Then finally copy the running configuration to the startup configuration. First of all, we will set the device name. Host name as S1. Coming to S2, host name as S2. Now we will configure the IP address as per our addressing table for the VLAN 1. Here we can see device S1, interface VLAN 1. Here we can see the IP address. Also we can see the subnet mask and the default gateway. Coming to S1, we have to go to that interface VLAN 1. Here we are going to set the IP address. Here is the address for the switch S1. Then the subnet mask 255.255.255.0. Now we will set the IP default gateway. It's 1.1. We will verify this configuration. We'll go to do show IP interface brief, and here we can see that VLAN IP address. So here we can see it's administratively down, right? So we did not give the no shut command on VLAN 1. We will give that. We will go to that interface VLAN 1 no shut, right? Here we can see the device S2 IP address, it's 1.12, subnet mask and the default gateway. We will come to the switch S2. We will go to the interface VLAN 1, no shutdown, and we will give the IP address. So here is that. Subnet mask 255.255.255.0. Also we will give IP default gateway, it's 1.1. Now we will disable all the unused ports on the switches. Coming to our topology, device S1, here we can see we used 3 ports here, F0/1, 0/5 and 0/6. All other ports we will disable. Coming to S1, we will go as a range fast Ethernet 0/2 till 4, then fast Ethernet 0/7 till 24. Also we have a 2 gigabit Ethernet 0/1 and 2. Here we will give a shutdown. Now coming to the switch S2, here we can see here we used two ports F0/1 and 0/18. Coming to S2, we will disable all other ports. Interface range fast Ethernet 0/2 till 17. We should not disable 18. Then we have F0/19 till 24. Also we have 2 gigabit Ethernet ports G0/1 and 2. We will give shutdown. Now we will save the configurations on both switches. Copy running config, startup config. Coming to S2. Copy running config, startup config. Now we will come to step 5. Configure basic settings for the router. Console into the router and enter global configuration mode. Copy the following basic configuration and paste it to the running configuration on the router. Here we can see the commands. We'll copy this. We will paste it on the notepad. Coming to the router R1. CLI. Initial configuration dialog, no. Enable configure terminal, and here we are going to paste those commands. Coming to C, configure the loopback 0 IP address as shown in the address table. Do not configure sub-interfaces at this time. They will be configured in part 3. And then copy the running configuration to the startup configuration. Coming to our addressing table, here we can see interface loopback 0 and its IP address. We will copy this IP address. Also we can see the subnet mask. Coming to router R1. Exit interface loopback 0, and here is the IP address. Also the subnet mask 255.255.255.224. Also we will save the configuration. Copy running config, startup config. Coming to part 2, configure switches with VLANs and trunking. In part 2, we will configure the switches with VLANs and trunking. Note, the required commands for part 2 are provided in Appendix A. Test your knowledge by trying to configure S1 and S2 without referring to the appendix. Coming to step 1, configure VLANs on S1. On S1, configure the VLANs and names listed in the switch port assignment specifications table. Write the commands you used in the space provided. Coming to our switch port assignment specifications table, here we can see the trunk for the ports F0/1 and 0/5 on S1, also F0/1 on S2. Also we can see the VLANs, VLAN 10 students, VLAN 20 faculty. We have to assign these ports to these VLANs. First of all, we will create this VLAN 10 and 20. Also, we will name as students and faculty. Coming to the switch S1. Configure terminal. VLAN 10. Name as students. I will create VLAN 20. Name as faculty. Here we can see the commands what we used on the switch S1. Now we will come to B. On S1, configure the interface connected to R1 as a trunk. Also configure the interface connected to S2 as a trunk. Write the commands you used in the space provided. Coming to a topology, here we can see the ports fast Ethernet 0/1 and fast Ethernet 0/5. We have to configure as a trunk on the switch S1. Coming to the switch S1, we have to go to those interfaces. We can go as a range, interface or range fast Ethernet 0/1, comma. Also we have other interface which is connecting to this router, that is F0/5. F0/5. Here we are going to give a switch port mode as a trunk. Coming to the configuration on S1, configure terminal, we will go to the interface fast Ethernet 0/1, switch port mode as a trunk. Also we will go to the interface fast Ethernet 0/5, switch port mode as a trunk. Here we can see the command we used on the switch S1 to configure this trunk. Also we can give these two interfaces as a range also. That also I will add it here, or we will copy this line. Here we have to give as a range interface range fast Ethernet 0/1, comma fast Ethernet 0/5. Then we can give this command. So that we can do this mode to trunk together for these two interfaces. Actually here it will display as if-range. Right. Coming to C, on S1 assign the access port for PC-A to VLAN 10. Write the commands used in the space provided. Coming to our topology, here we can see the device PC-A is connected to the port F0/6 on this device S1. So here this port F0/6 we are going to assign to VLAN 10. Coming to the configuration on this switch, we will exit and we'll go to the interface fast Ethernet 0/6, switch port modus access, switch port access VLAN 10. Copy running config, startup config. Here we can see the commands we configured on the switch S1. Now we will come to step 2, configure VLANs on switch 2. On S2, configure the VLANs and names listed in the switch port assignment specification table. We are going to create these two VLANs, that is VLAN 10 students, VLAN 20 faculty on the switch S2. Cisco enable class, configure terminal, VLAN 10, name as students, VLAN 20, name as faculty. Coming to B, on S2 verify that the VLAN names and numbers match those on S1. Write the command you used in the space provided. We are going to give a show command here. Show VLAN brief, and here we can see the details. VLAN 10 students, VLAN 20 faculty. So we will copy this command. Here is that. Coming to C, on S2 assign the access port for PC-B to VLAN 20. Coming to our topology, here we can see this device PC-B is connected to the port F0/18 on S2. So here this port F0/18 we are going to assign to VLAN 20. Coming to the configuration on S2, we have to go to that interface fast Ethernet 0/18, switch port modus access, switch port access VLAN 20. Coming to D, on S2 configure the interface connected to S1 as a trunk. Here we can see the port F0/1 is connected to the switch S1. We are going to give the mode as a trunk here. Coming to S2, We will go to that interface, fast Ethernet 0/1, switch port mode as a trunk. Copy running config, startup config. Now we will come to part 3, configure trunk-based inter-VLAN routing. In part 3, we will configure R1 to route to multiple VLANs by creating sub-interfaces for each VLAN. This method of inter-VLAN routing is called router on a stick. They given a note. The required commands for part 3 are provided in Appendix A. Test your knowledge by trying to configure trunk-based or router on a stick inter-VLAN routing without referring to the appendix. Right. Coming to step 1, configure a sub-interface for VLAN 1. Create a sub-interface on R1 G0/1 for VLAN 1 using 1 as the sub-interface ID. Write the command you used in the space provided. Coming to our addressing table here itself, we can see that sub-interface G0/1.1. We are going to create that on router R1. Configure terminal. Here is that command, interface gigabit Ethernet 0/1. The sub-interface is a .1. So here is the command. We will copy that. Coming to B, configure the sub-interface to operate on VLAN 1. Write the command you used in the space provided. We are going to give that command on the router R1. Here we have to give encapsulation. It's a .1Q. Here we can see the IEEE 802.1Q virtual LAN. Then we have to specify the VLAN ID. This is for the VLAN 1. So here we can see the command what be given. Coming to C, configure the sub-interface with the IP address from the address table. Write the command you used in the space provided. Coming to our addressing table, here we can see the IP address of the interface, the sub-interface G0/1.1 on this device R1. We will copy this address, and here we can see the subnet mask. Coming to G0/1, here we are going to give IP address. Here is the address. Then the subnet mask 255.255.255.0. We will copy this command. And we will paste it here. Coming to step 2, configure a sub-interface for VLAN 10. Create a sub-interface on R1 G0/1 for VLAN 10 using 10 as the sub-interface ID. Also, B, configure the sub-interface to operate on VLAN 10. Then coming to C, configure the sub-interface with the address from the address table. So coming to our addressing table, here we can see the details for the sub-interface G0/1.10. Here we can see the IP address, also the subnet mask. Coming to our router R1, we will exit and we will go to that sub-interface, gigabit Ethernet 0/1. The sub-interface is .10. And here we are going to give encapsulation .1Q VLAN ID. It's for VLAN 10. Also, we have to set the IP address as specified in our addressing table. Here is that. Then the subnet mask 255.255.255.0. Coming to step 3, configure a sub-interface for VLAN 20. Create a sub-interface on R1 G0/1 for VLAN 20 using 20 as the sub-interface ID. B, configure the sub-interface to operate on VLAN 20. C, configure the sub-interface with the address from the address table. So here we can see the IP address of the sub-interface G0/1.20. Here is that. Also, we can see the subnet mask. Coming to our router R1, We will exit and we will go to the interface gigabit Ethernet 0/1. The sub interface is .20. Encapsulation .1Q. This is for VLAN 20. So the VLAN ID is 20. And we will create the IP address. We will configure it. Here is the IP address. And the subnet mask 255.255.255.0. Now we will come to step 4, enable the G0/1 interface. So enable the G0/1 interface, write the commands you used in the space provided. So we have to go to that interface G0/1 and we have to give a no-shut command. Here we can see in this topology, this link between the device R1 and S1 is down. So we have to bring it up so that all the sub interface also will become up. Coming to the interface G0/1, and here we are going to give a no-shut command. And here we can see the messages. All the sub interfaces are up. Here we can see G0/1.1, 1.10, 1.20 changed state to up. So here we use the command. Here is that. Here we can see the command. Now we will come to step 5, verify connectivity. Enter the command to view the routing table on R1. What networks are listed? So coming to R1, here we are going to give show IP route, and here we can see the details. Here we can see connected the sub interface G0/1.1. Here we can see 1.10. Here we can see 1.20. Also here we can see the loopback. Next is from PC-A, is it possible to ping the default gateway for VLAN 10? We will try that. Coming to PC-A, desktop, command prompt. Here we are going to ping to 192.168.10.1. Here we can see we are getting the replay. Here the answer is yes. Next is from PC-A, is it possible to ping to PC-B? It should work. We will get the IP address of PC-B. Here is that. Coming to PC-A, command prompt. Ping to PC-B. Here is the IP address. Copy it something else. Right, so we will copy again. Coming back to PC-A, ping to PC-B. Here is that. Here we can see we are getting the replay. The answer is yes. Next is from PC-A, is it possible to ping loopback 0? We will get the IP address of loopback 0. Here we can see that. Coming to PC-A, command prompt. Ping to loopback 0. Here is the IP address. Yes, we are getting the replay. So here the answer is yes. Next is from PC-A, is it possible to ping to S2? We will get the IP address of S2. Here is that. Coming to PC-A, command prompt. Ping to the switch S2. We are waiting for the replay. Request timed out. We are getting the replay. Once more we will try. Yes, we are getting the replay. Here the answer is yes. If the answer is no to any of these questions, troubleshoot the configurations and correct any errors. So here we got everything yes. Coming to the reflection question, what are the advantages of trunk-based or router on a stick inter-VLAN routing? Obviously, using this, we can create multiple VLANs is through the use of an 802.1q trunk between one or more switches and a single router interface. That is very important. So here physical router interface is divided into multiple sub-interfaces that already we have seen that provide logical pathways to all VLANs connected. Means we can create and connect many networks using single router using this VLAN concept. Well, in this video we have seen configuring 802.1q trunk-based inter-VLAN routing. Friends, if you have any doubt in this lab activity, please comment below. Also, if you like my video, give a thumb and share with your friends. And don't forget to subscribe this channel so that you will get latest uploading video info into your Gmail. Thank you.